I wrote a book about the history of Earth and life. And I started noticing when I did my research that there were these statistically improbable events, seemingly, that had to occur in order for us to get life here, intelligent life, here on our planet. And SETI has been now searching for the search for extraterrestrial intelligence. They've been searching for life for 54 years, and they, of course, haven't found any intelligent life. And so I got to thinking, well, maybe they weren't finding it because it's extremely difficult to occur, evolutionary or whatever. So tonight, what I'd like to do is I'd like to give you 3 examples of these statistically improbable events. But please keep in mind that there are literally hundreds of these events which need to occur in order to get intelligent life on this planet, in my opinion. Well, I need to go back to the Big Bang and talk a little bit about the Big Bang Theory. And I hope to God that when I said the Big Bang Theory, that the first thing that came to your mind wasn't the television show, because we're all in trouble if that's the case. And it could be a long talk, too. Well, in the Big Bang, 13.8 billion years ago, there was hydrogen and helium. That's it. So scientists recognized that we need another source for all the other elements that we find in our universe. And we now know that that source is a supernova. And a supernova is literally the death of a giant star. It collapses in on itself. It forms all of the elements in the periodic table other than hydrogen and helium. And then it explodes and it sends that material out into its local space. Well, now I want you to picture something called a solar nebula. This is a gaseous cloud that once existed out there that later collapses to form our solar system. And that cloud was originally enriched only in hydrogen and helium. So we have to have all of these supernovae erupting out there and enriching that solar nebula in all of the elements requisite for life, intelligent life in particular, on our planet. And if we don't have that, then we can't get intelligent life. And then at some point, there has to be a supernova nearby our solar nebula, which forces it to collapse. Now, how do I know that there was a supernova out there that forced our solar nebula to collapse? Well, I think that's one of the most interesting scientific discoveries of all time, and it doesn't get much press, so I'd like to share it with you tonight. The Allende meteorite is believed to be material that formed from our solar nebula as it was collapsing to form our solar system. One of the reasons we know that is that it has calcium aluminum inclusions in it that date to 4.56730 billion years ago. So that's the oldest date that we find in our solar system, and we now use that date as the beginning or the origin of our solar system. Well, in these calcium aluminum inclusions is a strange thing. We find an isotope of magnesium called magnesium-26. And we shouldn't have magnesium in calcium aluminum inclusions. So scientists were puzzled over this, and they recognized, though, at some point that magnesium-26 is the decay product of aluminum-26. Aluminum-26 has a relatively short half-life of 717,000 years. So that means that in 7 to 10 million years, all of the aluminum-26 is going to decay away to magnesium-26. We don't have any aluminum-26 on the planet today. That's because it all decayed away billions of years ago when it first formed from a supernova. So I think you can see here what's happening. We had a supernova nearby our solar nebula and injected it with all of the requisite elements, including aluminum-26, and forced it to collapse. And as it collapsed, the calcium aluminum inclusions formed, rich in aluminum-26. And that aluminum-26 then decayed to magnesium-26, hence the reason we have magnesium in these calcium aluminum inclusions. So I don't know. I think that's an incredible scientific discovery. I'm a little prejudiced, but think about that. We can take things that we see today, we can look at them, we can study them, and then we can extrapolate back to things that were happening 4.5 billion years ago. It's amazing, I think. And where does the statistical improbability come into play here? Well, think about what has to happen. You have to have our solar nebula out there with just hydrogen and helium in it to begin with, and then you have to have all these supernovae going off, which inject it with all of these elements bigger than hydrogen and helium, and just the right amount, and none of them can force our solar nebula to collapse. And then you have to have this supernova, which we know occurred close enough to our solar nebula to force it to collapse. And when it collapses, at just the right time, when our solar nebula has just the right composition, then it collapses and it forms, and eventually it leads to us. Well, that seems remarkable to me. An improbable event, if there ever was one. And we're here possibly as the result of it. Well, that's the first statistically improbable event I'd like to talk about tonight. But the second one has to do with this graph. This is a graph of the log of brain mass versus the log of body mass. And one of the things I'd like to show on this diagram is I'd like to show the relative intelligence of animals on the planet. And in order to do that, you can't just show brain mass, you also have to show log mass, or log of the body mass. And I think you can see what I'm talking about when you see this field. This is the field for fish, amphibians, and reptiles. And as you can see, for a given body mass, these creatures have a lower brain mass compared to many of the other elements, or I should say animals on our planet. Well, you're not going to find any brain surgeons in and among the fish, amphibians, and reptiles, that's for sure. Look where the mammals fall. The mammals fall at much higher brain mass for a given body mass, and that's because mammals have a neocortex, and that's what evolved into our gray matter. So it's not surprising to see that the mammals fall higher than the fish, amphibians, and reptiles. And then the primates, you can see where they fall. They have some of the largest brains in the animal kingdom, and I'm going to talk a little bit more about the primates and explain why they might have gotten those big brains. But first I want to talk about and concentrate on this red dot, because the red dot falls towards low body mass and very high brain mass, and that's where people that come to TED Talks fall. Thought you might like to know that. Okay, well, we all learned from Jurassic Park that the dinosaurs were geniuses. I mean, think about this. They learned how to open doors, for God's sakes. But I'm here to tell you that they weren't as smart as we think they were, and Jurassic Park was lying to us. Look where the dinosaurs fall, towards very high body mass, but relatively low brain mass. They weren't the sharpest knives in the drawer, that's for sure. Well, now, once we get the dinosaurs, and we see how they fall, this brings me to an important point, and that is about evolution, and that is that evolution doesn't always select for the brightest creatures. In the case of the dinosaurs, they were selected for their large body mass, and they were immensely successful. They ruled the planet for 135 million years. And what were mammals doing during that time? Well, the mammals first appear in the Triassic about 200 million years ago. They were little tiny creatures scurrying around trying not to get stepped on by the dinosaurs. And they were that way throughout the entire Mesozoic. And if it weren't for the demise of the dinosaurs, I'm going to suggest to you that we'd still be little tiny creatures running around, and I wouldn't be up here talking to you tonight. And it's that demise of the dinosaurs that leads me to my second improbable event. And that has to do with the destruction of the dinosaurs. These are the Alvarezes. They're standing next to what we call the Cretaceous-Tertiary boundary. It's an ash layer, and that ash layer was deposited by, the Alvarezes discovered this, 66 million years ago by a meteorite impact that struck. It hit Mexico. Well, it didn't hit Mexico, but it hit 66 million years ago. Mexico wasn't there, but you get my point. It hit in that area, and it sent ash into the atmosphere. And that ash was carried around the planet by the atmospheric currents. It caused the planet to be darkened for months, and it stressed the largest animals on the planet, the dinosaurs. It wiped out every one of them. And here's something that a lot of people don't know. It killed off 75% of the species on planet Earth. It was a horrendous event. Now, where does the statistical improbability come into play here? Well, think about this. The Alvarezes discovered that meteorite was 10 kilometers in diameter. If that meteorite's a little bit bigger than 10 kilometers, you might kill off all life on the planet. And if it's a little smaller than 10 kilometers, you might not kill off the dinosaurs, and we'd still be little tiny creatures. So I hope you can see the fine-tuning that's required here and the fortuitous event that this must have been. Think about it. We have to have just the right size of a meteorite striking planet Earth in order for us to get here. That seems like a statistically improbable event to me, and I hope it does to you too. So what happens after the dinosaurs are gone? Well, we see the mammals radiate out into all of the niches previously held by the dinosaur. And one of the areas that they radiate into are the trees. And the trees are where we get primates. And when you're jumping around from limb to limb, a lot of the things that are required of that process are things that need big brain power, a lot of computing power. So we see big brains. Let me give you a couple of examples. The primates have three-dimensional vision, they have color vision, and they have these digits. And it takes a lot of fine motion to move these digits. So it takes immense computing power. And not surprisingly, these things that were selected for in the primates, well, they also come with it a big brain. And so we see big brains in primates, as you saw in that graph I showed you earlier. Now, I hear from certain sectors that we were given digits so that we could type on computers and throw footballs, but that's not the case. We have digits and three-dimensional vision and color because we evolved from creatures that once lived in trees. I hope that's obvious. Well, here's where I'm going with this, and that is that we need this event to take place, and we need it to take place, that is, getting rid of the primates. We need to get them out of the trees and onto the ground. And this is where the third statistically improbable event takes place that I want to talk about tonight. And it has to do with the East African Rift Zone. The East African Rift Zone started tearing Africa apart about 10 million years ago. And it's been rifting Africa apart ever since then. The faults are in red here. The large triangles, they're big volcanoes in the red. And those blue dots, those are hominid localities. Now, I don't have all of them on there, but most of the main ones are on there. And these hominid localities are where we find fossils of upright walking bipedal creatures. I mean, if somebody says to you, well, where are all of the missing links? Well, show them this diagram. That's where all the missing links are. They're everywhere out there. We not only have our direct ancestors, we have our first cousins, our second, you name it, they're out there. You know that 7 million years ago, we find a fossil that was walking in East Africa upright, and it had bipedal motion, and it had a brain about the size of a chimpanzee, and it's just when genetic clocks tell us it should be there. So I think that's amazing. So what has to happen to cause this bipedal walking motion and the big brains that we have today? Well, it has to do with the East African Rift Zone. The East African Rift Zone caused conditions to dry and become arid in East Africa. And it destroys the jungles and it forces the primates out of the trees and onto the ground. And then we see this amazing thing happening. We start to see these creatures that are walking upright, we start to see them develop amazing sized brains. And it's like nothing in the history of life on the planet. I'm not kidding you. We don't see this anywhere in the history of life. And I'm going to give you an example here. Australopithecus, about 3 to 4 million years ago, it was an upright walking creature. It had a brain just a little bit bigger than a chimpanzee. And this Australopithecus dude, it evolves into stone tool makers, then Homo habilis, Homo erectus, and then us, Homo sapiens, and it moves on to Africa 100,000 years ago and populates the planet, us. And that happens because of aridity in East Africa. That's an amazing event, in my opinion. And where does the statistical improbability come from? Well, think about this. If this was an East South American rift zone or an East North American rift zone, we might not be here. That rift zone needs to cause aridity where the primates are, and not just the primates, the largest primates, the great apes. So it has to occur in East Africa. Well, that's a fortuitous event, an improbable event. Now, I don't want to come from an anthropocentric point of view tonight. I'm not suggesting that a God made all of these statistically improbable events occur so that we would be here. That seems mildly arrogant to me. No, what I'm suggesting is that in a nearly infinite universe, that there might be a few localities where you have all of these statistically improbable events occurring at just the right times to get intelligent life like us. But in most of the places out there, and I'm talking about the rest of our galaxy and most of the universe, you might have a few of these statistically improbable events, but not all of them, and not in the right order. And that's why I think that SETI is having trouble finding intelligent life. Now I'm not on some campaign to shut down SETI. I'm not on the warpath to get rid of SETI. That's not my point here. In fact, that's a relatively negative point of view, and that's not the way I want to finish. I want to finish with a positive point. And my point is, and I hope you recognize that life is very, very rare. I mean, think about how difficult it was to get our species here. And then I want to point out to you that every one of you are rare, very rare. I mean, think about this. I mean, every one of your ancestors, and I'm talking about your parents, your great-grandparents, your grandparents, all the way back to the first cell, every one of them had to be successful at least one thing, and that was getting their genes passed on to the next generation, and if they weren't, you wouldn't be here. Well, that's amazing. I think of the gazillions of things that had to happen in order for you to be here. Well, it's an astounding thing. And so what I would like to leave you with tonight is that life is rare, life is precious, and we need to take advantage of it. And I can't see it, I don't think, any better than John Lennon. So I'm going to leave you with John Lennon's words tonight, and I want to thank you very much for this opportunity to come and speak to you. Thank you.